I'm Alex Poltrak. I'm the General Manager of North American Operations for Procemex Inc. We are based out of Greenville, South Carolina. Procemex as a whole was first established in 2000, and our main goal from the very beginning was combining web monitoring systems, WMS, and web inspection systems, WIS. I'll probably refer to those as WMS and WIS moving forward. Since 2000, we have always focused on the paper, pulp, and tissue industries only. We've always designed our equipment to be reliable, innovative, and simple, and our driving design has always been to withstand the environments that we see on paper machines. Since 2000, we've now installed over 1,100 systems, and that includes over 800 WMS and 300 WIS. The case that we're looking at today is for a high-end customer that needed a level of inspection that exceeded what they had previously. In 2018, we supplied a WMS system consisting of 4 cameras, which has since been expanded out to meet this mill-specific needs. In 2021, we found that their quality standards had improved, and we needed to provide a system that met their needs. So the first step in our web inspection process is to clearly define what the needs of their customers are. Once we have that established, we can then begin designing the application for their specific mill. For this case, they provided samples which went to our office in Jyväskylä and then went through full testing with all of our light geometries. When determining the best path for web inspection, we look at light measurements, which are different geometries we can put on your web. For this case, we actually have 7 light geometries. On the top side, we are doing UV, transmission, high angle reflection, and 3D measurement. On the bottom side, we're doing 3D and high angle reflection. We also offer a low angle reflection, which we are expanding out at this mill on another line. These different measurements are used for different defect types. The high angle or bright field inspection puts the camera and the light right next to each other to provide a direct reflection. For defects that aren't visible in a normal lighting, we used UV, which provided completely different parameters to detect the defects. For transmission, we put the light underneath the web and the cameras on top to look for the light penetrating the web. This also helps with formation and detecting wrinkles. The final light geometry that we used on the top side was 3D detection. 3D detection is built to detect topological defects, including indents, outdents, backing roll marks, and other items like that. By utilizing multiple light geometries, we can take the transmission, the reflection, and the 3D characteristics to build out proper classifications for this project. For low angle measurements, we put both the camera and the LED at a low angle to the web. This is often referred to as dark field inspection. We can use low angle reflection to better detect coder streaks, wrinkles, poly marks, and often defects that are not visible to the eye just looking straight down at it. This additional light geometry allows us to add even more characteristics to the defect detection to better determine what is in the web. Because this application was hotter than we expected, it gave us an opportunity to work directly with our customer to provide a solution that met their specific needs. For this specific application, we had to provide an insulation blanket to further protect their cameras due to the excessive heat in this environment. By combining the web inspection with a winder automatic target control, we can then control your winder drives to stop within defects within 3 feet. By putting a simple binary code on the edge, we can determine linear footage and stop the winder at any point. This gives your winder operators complete control over which defects to slow, run through, or stop on to prevent winder breaks and improve runnability. Our OnePlatform system pairs both our web inspection and our web monitoring systems together into a single user interface. This allows your users to quickly determine root cause analysis of defects by selecting it on the web map and then finding it further up your machine in a quick process. All of our systems work off a virtualized backbone, which means whether you have 4 cameras or 400 cameras, you have a single server that drives everything. This virtualized backbone can live on the mill server, or it can be provided by Procemex. Because we use a single virtualized backbone, your system all integrates together with a single user interface. That means when your web inspection detects a critical defect, it will automatically synchronize with your WMS cameras up your machine to quickly find root cause analysis. After our web inspection has detected your defects, we can take this classification one step further with our AI-enhanced application. These AI-enhanced applications can also be used to monitor your ropes to determine wear in real time, and also monitor the location of your dry line on your table. This will further enhance your paper-making process to improve quality and production to meet your needs. Our goal is to deliver solutions for our customers so that we build a solid partnership. We do not drop off our systems and walk away. Our goal is to continue to build your system as your quality improves. For more information, please visit procemex.com.